This is the Amp Hour Podcast. Released November 7th, 2021. Episode 565. Here for a reason.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Campbell of Contextual Electronics.
Who's eating at the same time. The other week it was PCBs, now it's eating.
Yeah, well, you know, I'm a new parent. I have a lot of things going on, Dave.
Right. How's all that going?
Oh, great.
Yeah.
Oh, my daughter started eating like solid food, and it's just it's just like messy food time all the time.
Oh, yeah, no, of course. Yeah.
It's a lot of fun. A lot of photos that nobody cares about.
Yeah, of course.
Very
Yep.
cute baby, but covered in food.
Yep.
I think it's adorable, but everyone else is like, that's gross, Chris.
And as soon as the second one comes around, it's not adorable anymore. It's just annoying.
Exactly. It's just a thing, you know. I have more to clean up. Yep. Yeah, it's going good, you know. Yeah. Balance and stuff is tough, but
I was going to say, has it changed your work lifestyle at all?
I think it's, you stop working whenever you need to, and then you just come back and you just kind of work all the time anyways, right? So that I think that actually is like, if I had a setup like yours where I had to go to an office and come home, like that would be really tough. So
okay, right.
It's nice to be, my lab is like down the hall from my bedroom, which is
exactly
has downsides as well, of course, but I think in this specific scenario during a pandemic, it's probably the best scenario I could have. So
yep, totally. I agree. Unfortunately, my other half does not agree. Because we're actually in discussions at the moment about expanding the house. About expanding the house upwards.
Oh, interesting.
Because our kids are getting older now, and you've been to our house. It's not huge. It's just a typical little small single level.
I mean, it's a good size, I think.
But it's okay. After we added the back room, which you slept in, which, whereas before that back room was not there. So back then we had practically nothing. Well, I'm not going to say nothing.
I think just as your kids get older and you have more loudness and attitude.
And they have more friends over and, and they want their own space and stuff like that. So, we're thinking about going up, of course, because we can't expand outwards. Our land's not big enough. The small amount of backyard that we actually have, we don't want to
think of the solar panels, Dave. Think of the solar panels.
They'll actually be better because they'll be mounted up higher, and then the bloody house on the high side of us won't be
closer to the sun.
Exactly.
That's how it works, right?
That's how it works. I get the point. I'm sure you can calculate how much. 0.000% efficiency.
Right.
Actually, somebody asked me this on Twitter. It was a couple of years back, I think. I greatly doubt I could find it, but somebody asked, your solar panels are still generating power under moonlight. And then I thought, I wonder, technically they would be, right? And then I thought,
that gets into like dark current, and out of a diode almost.
Right. It's, so I can't remember the exact details, but I went and did the calcs. I found some data. It wasn't easy to find, but you can find lunar insolation, not insulation, insolation. So if
ENSOL.
Lunar. Oh,
I would just think if you went to go and measure it, wouldn't that load it down? Like at those levels, wouldn't that also load it down even with a high impedance measurement?
Well, the thing is, I couldn't, my solar output, my solar monitoring system shows 0.00. Right. It's so it's not there, but I know they must be actually possibly producing something. So you just basically run the numbers based on the lunar insolation and then the watts per square meter kind of thing, assuming it's linear right down at that lower end, et cetera, et cetera.
Yeah. Cause when they're usually measuring solar cells, aren't they usually doing it by loading them, trying to find the peak point and actually loading them through the curve?
Oh yes, the peak power point. Yes, the maximum power point. Yes.
Yeah, so that would be really hard to find, I would think, for if you're basically not biased at all because you have no.
I'm sure you wouldn't be able to do it. Probably, I don't think it's possible. I just in theory, what would the moon actually produce? And it was and it was like microwatts or something. It was like even from a 3 kilowatt array, which I had at the time.
I mean, you're only 5 months out from April Fool's jokes, so like you could probably talk about like how you found, So just keep an eye out, folks. If you see something about like late March about Dave working on a new thing about the solar energy harvesting or lunar energy harvesting.
Oh, it's good enough to power all your Internet of Things, lunar energy harvesting to power all your Internet of Things widgets. Yep.
All you need is a boost circuit.
Yeah. What's the name of that boost circuit? That famous like single transistor boost circuit that like
the Joule thief.
The Joule thief, yes, Joule thief. Yeah, I can somehow combine it with a Joule thief and like lunar charging.
Except you need like a super Joule thief or like Joule heist or something like that.
A lunar thief. Lunar thief.
Bingo.
Yeah. Trademark. I could make serious coin on that. That's got Kickstarter written all over it.
That's right. He's also going to be starting a crypto coin based on this.
Yeah, right. Yeah. Anyway, geez, how did we get to lunar insulation and?
Because you're going to move your house closer to the moon and get more insulation.
Roof. Because we were talking about house. Yes.
Yeah, exactly.
Talking about house expanding. And so we've sort of come to the conclusion that we'd have like one gigantic great room up there or something, because we don't need extra bedrooms or anything, like just one huge gigantic room the length of the house or something, just to, I don't know, do stuff in. And I went, oh, I could have a lab at one end. And the death glare. I got nope.
What I could do is I could bring all this craziness home and
yes.
I've got so many monitors now.
Right. And that was a nah, as we say here in Australia. Nah. Straight away. That was vetoed. So I get this question all the time. Oh, why don't I just work from home? You'd build a lab in the backyard. No, even a separate lab in the backyard, even if we had the room, the answer is no. I'm not allowed to build a lab.
I mean, the isolation or the separation is nice, I think, at certain points. But in my current season of life, it is not.
Right. So I do believe the reason is that once I'm home, I'm supposed to be home. I'm not supposed to lock myself away in my man cave and my man lab and do things. I'm supposed to like spend time with the family. So that's like as soon as I'm home, I'm home. That's the idea. Otherwise, if I had a lab,
you could bring everyone into the lab. That's the counter argument. You can be like, Mrs. EV blog. This is how it's got to be. Everybody could join me in the lab. Bingo.
Nah.
Or at least the kids.
Not going to happen. Anyway, so there you go. Yeah. So I'm glad that your one's on board with that.
Yeah, fight the good fight, my friend.
It's not winnable. Anyway, what do we have on today's show? Is there anything? Not that we planned any of this shit beforehand.
There's some stuff.
Speaking of talking efficiency,
about... okay, go ahead.
In conversion and stuff like that. Great Scott did a place. Okay. Great Scott did a great segue. Great Scott did a video on synchronous converters, of course, which are pretty much the duck's guts of converters. If you want the most efficient DC to DC converter, it's basically going to be a synchronous converter. And for those who don't know what it is, the TLDR is that basically it's like any regular, whatever your favorite DC to DC converter topology is, it's exactly the same, except those pesky power losing diodes replaced with a switch with an intelligent FET, and then you don't get the losses. You don't get the same amount of losses as you do in diodes, because diodes have to start conducting, and they've got power loss, and they got pesky little things they are, but they're cheap and they're simple. And they just work, right? They don't need any intelligence behind it. They don't need any timing.
Control schemes.
And all that sort of stuff. Because you can come a gutsy. You can't just do a synchronous... Well, I'm not sure. I haven't watched the Great Scott video. So I think he built one up on breadboard or something, but I'm not sure which controller chip he used or whether or not he tried to roll his own or what. I'm not sure. Have you watched it?
He did a matched FET pair for it with like a FET driver rather, and then he drove the whole thing with PWM out of a Teensy, And I think he was doing some measurement feedback and stuff too. But
Okay, right.
Teensy's
So he's
got
doing it
great.
himself. Okay.
Yeah.
Yep. Well, yeah, you can Kamagutsa doing this. I'm not sure if this is mentioned in the video, but you can get shoot through if your FETs are all conducting at the same
That's right.
time. You can, so you've got to have a little back off there. So that's why you've got to have intelligent delays in there and stuff like that. This is why you have dedicated synchronous converter chips and stuff like that. So you can absolutely piss away all of your power savings if you don't, if your transistors are all conducting at once, or they're switching over at exactly the same time, and then you've got a tiny little period of time where they're both on, and bam,
that's the controller piece is that. So the FET driver rather that has like a delay between the two. So like
it does.
Even if you drive, so you drive with like a digital input, but then it controls it, so it's not just popping one on and off at the same time.
Yep.
It's
and that's what a good synchronous converter chip will do. Yeah. What efficiency did he achieve in the end? Did he say?
Spoilers, come on, man. He said 92.
All right.
92, even though 95 92. Was the theoretical.
Okay.
Yeah.
Right. Yeah. Okay.
Yep.
Cool bananas. So they're synchronous converters.
Yeah.
But generally they cost more and
I just met up with a friend last night who works on converters, actually, and so we were talking all about it. I'm going to try and get him on here. I'm not sure how much he'll be able to talk about, but hearing about it, so he's at a chip company, and hearing about it like at the chip level, it was very interesting just hearing about like how they communicate with their customers and like just everything. It was just very, very interesting hearing about how it all kind of fits together. And I hope to have him on sometime soon, because I think, like we've talked to people from the chip industry before, and we've talked to people in different parts of the chip industry, but like the pure analog side of things, I guess we've talked to people like we've had Matt Duff on before and Hank Zumbalin, and we'll try and link those in, and that's kind of more on like the analog measurement side. But I'm not sure if we've had people on the power switching side. Do you remember?
I don't recall as such. No. So.
So it might be interesting.
It's a good topic.
Yeah.
Yep.
But like I said, I'll definitely link in Hank. And so Hank Zumbalin, I think he's still at Analog. Actually, Hank and Matt were both from Analog Devices. I guess we've had Mike Engelhart on from Linear, LT Spice.
Yep.
And so we'll see.
Cool bananas.
But I don't really know how it all, like for me and for you and for most people, I think it's just like buy the chip, do the app note, hope for the best,
you run the app note thing. Yeah. It's like, no, rarely do I have to delve into, have I in my entire career delved into the, the nuts and bolts of it all. It's like, rarely do you have to do that.
Right.
So there's just so many chips out there, right?
I think on here and I think elsewhere, but like at least on the consulting forum we talked about a little bit too. Like in the time of part shortages, like do you try and then maybe go and try and build your own synchronous? So like Grace Scott was doing it for educational purposes. I don't think it was for actual like designing your product.
Wouldn't. No, exactly.
But like you in theory you could go back to transistor level designs and do that sort of thing. And I think we mentioned that on here too. But it's just like. I mean, the maintenance and the overhead and like just so much is taken care of when you buy an off-the-shelf controller that, I don't know. Exactly. I don't think I'd want to do that.
Well, it depends on the requirements of your design. I mean, if you're after, like, if efficiency is a real big deal, then you're going to be, cornered somewhere, right? You're going to be stuck in a corner where, you can't just whack in anything. Or you could actually design in a board solution, right? So like a daughter board DC to DC converter. So if that changes, well, your main product doesn't change, but then you design, you just very quickly roll a new DC to DC converter board.
Yeah. Test that it hits your specs and
so
that makes sense.
That isn't too hard to do. So, yep.
Sure. Yeah. But I just think if you have tight specs like you're talking about, and if you have, if you have to hit all these marks, then you have to kind of just really monitor that. And then you start thinking about like, a lot of the tolerances that are built in too, whereas a lot of the tolerances that are happening at the fab and tested for the fab and, like as things come off the line, you're usually getting that, you get that for free when you pay for the chip and the IP and whatever. Right. Yep. But when you then buy, random Joe Blow transistors off of somewhere and they're not matched and you just don't really know much about them and they're not characterized, then you start having parasitics everywhere that you don't know about. And it's like, oh, okay. And then, so then you have to, testing kind of gets pushed back at that module level, like you're talking about. And it's like, so if you don't catch it, then you might have some weird ass behavior. And Okay, good luck. So it seems good in theory, but it's it's not necessarily easy.
Yeah.
One last thing on it. There was a talk back in the day. I think it was Werner. Let's see if I can find it. But it was an HDDG talk back when I was doing those things, and he actually forget Werner's last name. He was basically going through and showing how to do this control scheme with it was like an Atmega or something like that. And so he was doing like the actual control and feedback system, and actually implementing like PID loops and stuff like that. So I'll try and link that in as well, because it is non-trivial.
Right.
So yeah.
Got it. That's another way that you can reduce your at the design stage, you can actually use your microcontroller as, assuming that your product has a microcontroller, right? You can actually use your microcontroller as part of your DC to DC converter solution. So then you aren't reliant upon yet another specific DC to DC converter chip. Then you're only reliant upon the external passive parts, like, transistors are active parts, but you know what I mean. You're only reliant on those, which you can find substitutes for with greater ease than you can if you're locked into a specific DC to DC converter chip. So that's something you can implement at the design stage. I'm going to do a video on that, like how to design your products to minimize impact of component shortages and stuff like that.
Oh, that's good.
Yeah.
That's it is topical, I gotta say.
Yes, yeah, totally. So I should have done it 6 months ago or something. But anyway, better late than never. So
yeah. I mean, it's not going to go away anytime soon.
No,
I mean,
exactly.
The chip shortage is not, of course, but also the concept of designing for.
Oh yeah, of course.
Supply chain stability, I suppose.
Yep.
Yeah.
That's it. All right. Somebody who's the smart ass? Hang on.
Oh, is this the Aussie plus plus?
Yes. Maybe Dave. Was that you?
That was me.
That you?
Oh,
that was you.
That.
Oh, okay.
Yeah, totally.
You're the smart ass.
I'm the smart ass. Yeah.
Maybe Dave's reticence.
Yeah, like reluctance. Yeah.
Right. Well, why didn't you use the word reluctance?
So that people like you have to ask, why didn't you use the word reluctance?
Bastard. Maybe Dave's reluctance to write code is just that he hasn't found the right language yet. Introducing Aussie plus plus. And sure enough, this is a real thing. You can actually do it. You can, Playground, I can actually go in there and I can actually type code. And
so it's Rust based, I believe. I think it's been around for a while. Yeah, it's great. You can go in if you go to the Playground, you can.
Right, I can type around with it. No, I'm not going to. Right,
yeah. No, it's great. It's great. So, the delay is. Oh, I reckon I'll have a walkabout until and that's in the parentheses. It's great. Aussie
Somebody
syntax.
actually spent their time to write this. And make it functional. Wow.
I think it was inspired by Reddit. So yeah, bingo.
Yeah. What's randombeer.aussie? Oh, okay. Oh, these are different examples they've got. The hard yakka for random beer, Foster's, Cooper's, and Pilsner. Flamin' L, you beauty. Yeah, dunno. This is just.
I think you should endorse this. You should lean into it. You should lean into it.
Okay.
You should be like, you should only say you're in a program in this. And then you could also say you've been doing Rust, which is, its own.
Okay.
Every time you hear about Rust as a programming language, you can be like, which has a very, very strong group of fans. You can be like, well, I'm only into certain dialects of Rust.
Right. Okay. I'm only into the Aussie dialect. Yeah.
That's right.
Aussie plus plus. Yep. All right. Yeah. Yes. This is officially endorsed by the EEV blog.
All right.
Aussie plus plus. Yeah. Great. So can you actually compile for sources?
I don't know.
Or is it?
Well, yeah, I don't know. I didn't get that far.
Somebody hasn't wasted that much of their life on it yet. This is great.
Yeah, I mean the Rust crowd is interesting too because so this is its own thing layered on top of that, but the Rust crowd is very into memory protection and stuff like that. So basically, you can't have multiple pointers kind of overwriting memory space.
Right.
It's very safe in that way. And it's like any programming language. It's not like any program. It's like many programming languages where, it's just like you got to get into it. You got to learn the lingo. Like I think when you are doing something unsafe, it like actually has that, like it actually, you have to like type unsafe or something like that, so that it's very clear that you're doing something that's like memory unsafe. And so, yeah, I've done a video about it. Yeah, exactly. It's like, it's saving us from ourselves. So that sort of thing. The thing that I'm against with it, is the same thing that I'm usually against, is just like, there's not enough stuff out there about it yet. So like, as it continues to grow, I am a very late adopter when it comes to programming languages, because I don't have the time and or inclination to go and write a bunch of new drivers and do a bunch of stuff. Like some people are just like capable of spinning that stuff up, and power to them. But I am more like, how about something I could start from that's very well covered in lots of languages, and C is still that for me. So,
got it.
So I will not be using Aussie++, but you are welcome to.
The protection thing reminds me of, you're doing something stupid. I think I did an example of this in my 1024th video, where I showed some old PIC code that I wrote that actually compiled into 1024 words of memory, not bytes, words of memory. 1024 program steps. And I wanted to see if I could recompile it 20 years later. And I did. It worked first go. I imported this old assembly language stuff, but it came up with these error messages saying, are you sure something along the lines of, are you sure you know what you're doing with these banks? It's like, I'm
old.
sure, Yep, I do know what I'm doing with these banks. Thank you, this bank switching. Thank you very much. I've read the data sheet. I know what I'm doing. And, but it warns you that, you may be potentially doing something really dumb here, but there's reasons you would want to do it. And back in the days when, you were optimizing your code to fit in 1024 words of memory.
Yeah, right. Totally.
It was, yep. But yeah, it worked. So good stuff. What is
definitely
stop motion assembly? I must watch this.
Oh, stop motion is like that's like a style of
yes, I know,
like animation, basically.
Sorry.
Oh, okay.
Yeah.
Okay.
Yes, I know what the thing of stop motion is. I want to see what they're building and what it looks like.
Oh, got it. Yeah, it's like a Raspberry Pi based radio,
right?
Which is pretty cool. And it's just like, so this artist does these renderings, and so she kind of put it all together, and it's amazing because like it looks like she spent a whole day setting this thing up, and then the animation that it produces is like 10 seconds. It's like, wow.
Right. No, it's a huge amount of work, right?
Yeah. It's really cool though, the output. So
all right.
Yeah,
excellent.
Yeah. Speaking of Raspberry Pi, there is a new one in the world, the Raspberry Pi Zero version 2. How are they naming this thing? Pi Zero 2 W.
Do we care anymore? Do we care anymore?
Well, I like the form factor. I think the form factor is, interesting. I've always been curious about how it, it has a host and a device, USB port on it, micro device or micro USB port on it.
Haven't even used my Raspberry Pi Zero that I got.
I don't know if you are the target audience here, Dave.
I know. Oh, bloody hell.
I see a lot of people using these in things like print servers, like what do they call it?
Right.
Octoprint and things. I think that's really what it comes down to, is just it's a readily accessible, obviously very cheap Linux computer. And it's just a good example of that over and over again, right? Anytime you see one of these out in the wild, it's like, oh, someone wants to, you usually don't see them as much, I think, on the GPIO side of things, so much as just, oh, I need something to have HDMI and control. Maybe it has a little board on it, but I think it's really just kind of having computing in the wild. And that is, I think, very, very useful, especially if it's lower power, right? So this one, the article that we linked, couldn't remember the word for some reason. The article that we linked is from Hackaday, and it was just most efficient. And yeah, I mean, like, so getting low power Linux computing is better than high power. So,
yeah, this is low power. They deem it to be under 2 watts, do they, or something? I think.
No, I think you're getting that from the title. It's
the 2W?
Pi Zero 2W. Pi Zero 2 as in version 2, W as in it's wireless. It's got a Wi-Fi.
Then, okay. Here I am thinking
it does look like 2,
Right. Okay.
Yeah.
Got it.
Yeah.
Oh, boy. I would presume it'd take around about that 2 watt mark, doesn't it? Oh no, the original
says,
Raspberry Pi, I think idles around about 2 watts because you can just run it on a 500 milliamp 5-volt USB port, I think, just if memory serves me correctly. So that's about 2.5 watts.
I've not done that in a long time. Usually
Right,
I have to have a
I'm scraping the
extra
barrels of my
spicy
memory.
power supply.
Right.
Yeah. No. I've had many Raspberry Pis brown on me before. They're not forgiving.
No, idle. Here it is. The Raspberry Pi 2.0 idles at about 275 milliamps, and when you stress the poor little sucker, it's about almost 600 milliamps. Yeah. The 0.2 actually consumes more.
No, this is the chart says less than 100.
Well, no, I've
chart
got,
says.
Okay, I've got another Tom's hardware review. Has a graph of idle, the Raspberry Pi 0.2W. There's the 0.2, it idles a bit more than the zero, so it's actually consumes a bit more power.
Yeah, probably because of the Wi-Fi and stuff like that. So
I don't know where you're getting hundreds. They're saying that they saw 260 milliamps idle. So there you go.
It doesn't really matter to me. I mean, like I don't know. Like
matters.
I think
this is
it does matter. It does matter. But I'm saying that I'm not sure it matters in the context of like it's still a lot. If it's less or more than the zero original.
Oh yeah, it isn't a microcontroller. If you're using one of these things just to flash some LEDs or something, then you're really the power's just being pissed away. So yeah,
and I think that continues to be the case for Linux machines out in the wild. It's like you still need to have a good wall supply or huge battery. I see people that are trying to do, and you can do like solar back charging, and I've seen that sort of thing too, where people will put a Pi with a big solar bank and with a big battery, and it's just like maybe with a controller that shuts the Pi down and like kills its rail or something.
Fairly niche, that's pretty niche. You got to have some outdoor application, and it's like
I think the thing when I see that sort of stuff, it's usually like, oh, I want to do like some kind of like vision model. You have a camera, like a trail camera or something like that.
Right.
You're right. That is a very niche thing.
Yeah.
But if you had a trail camera, you wanted to detect things, you wake up, take a photo, go back to sleep, that sort of thing.
Yeah, of course.
So, it's usually you need some kind of co-processing. Actually, I just had a call. Someone just randomly like reached out to me about an internship. And so I had a call with him, and I didn't have anything for him, but we were kind of talking through, so it just turned into like this ad hoc mentoring session.
Yeah.
And I had asked what he had done before and all this other stuff. And he's like, well, I've done some C stuff and I've done some low level embedded things. And I was just kind of like encouraging him to like try and have a bunch of things in his tool belt, right? So like knowing how to use a Raspberry Pi or, CM4 or whatever, like some kind of Linux computing platform, that is very useful. I think, he was saying that his robotics team is using a Pi for doing, I think vision processing, things like that for the robot. But then I was like, well, how are you going to control the wheels and, like the low level functions? And so you need to have the fast, you need to have all these different things. And like you've talked about before too, is like, I think it's good to kind of find your favorite, right? It's good to have, or like Mike Harrison always does, is like you just have that one tool that you always go to. His pick 32, he just keeps going back to it, right? Yeah, like you did pick 24 for a long time, or 16.
Yes. Yep.
I mean,
both.
Yeah, and just being able to like have that thing, it's not a bad thing to go and reuse this over and over again. I think it's actually very efficient, and I think the tough thing then for a younger person coming into electronics is you just got to go out and find that, right? And maybe do a survey of everything that's out there and see what works for you, right? So like you might figure out that like, an ESP32 is great for this application, but it still has really high idle current, so I need to go and do something super sleepy, and just get like a tiny little microcontroller that'll maybe just do the same thing and wake up and kill its rail and to the Raspberry Pi or the ESP32 or whatever.
One of the things that would bother me if I was looking through someone's resume, I've got experience in ARM, right? They try and like, it's like,
that's a pretty broad brush there.
That's pretty, that's not really a useful skill in its own right, but if you go, oh yeah, I'm familiar with the STM32 chain, or where to insert other specific,
F0,
I know,
L0,
yeah,
something
exactly.
like that. Like
I
you could
know how to get
determine.
the job done using this tool chain. Just because,
Mm-hmm.
I know how to program microcontrollers, or I know how to program ARM, or I know how to program, something or other, doesn't really impress me much, because that implies that, you can probably figure it out if you
Sure. Yeah.
had enough time, right? Sure. Okay. Right.
Yeah.
Great. Okay. That's a base level skill, but it's not a specifically efficient practical skill that can be put to use straight away.
Mm-hmm. Yep.
Whereas if you've got a skill with a specific tool chain, for example, then yes, that's much more value, because you can hit the ground running and boom, actually make something straight away. So
yeah, I think that actually is a good way to frame it too. Is like, so like we've said many times on the show, showing up with a project, and this is what I told this person too, is show up with the project, that's good. But then I think the next level down from that is and here's the tool chain I use, right? And so this is what I could deploy quickly and with a little bit of knowledge towards it. I think like not overselling it too, and just being like, I've used it. I don't know everything about it, but someone who says they know everything about it, they better have 20 years on the resume for it, or equivalent. So, but I think that's where humility comes in, and then and then you could talk about it. I think then you frame the conversation. It's great. So yep. Same old answer from us on that one.
Yeah, it is. I know. Jeez, we got
the hard part is the learning, right? And putting in the doing the engineering in the dark dungeons at night, right?
Exactly.
Like we talked about 2 weeks ago, and then you did another video about it recently.
Did I? I don't know.
Yeah, about the flux, and you extended it on the flux.
Right. Yes, about working on your own in your silo, as they call it, is the wank word.
Yeah.
Yep. Engineers are much more efficient in their silos. Thank you very much. Just leave them alone, and they'll produce miracles.
Oh yeah, there's that might be a little bit of a stretch, but I think the leaving alone is fine.
All right. What else we got? I think we're running a bit skint this week, aren't we?
Yeah, I mean, I could talk about. I'm on the hunt for a new engineering laptop. Does that?
No, I don't give a rat's ass at all. No.
I think it's interesting because of.
What's the difference between a normal laptop and an engineering laptop?
Did I use one for work? I don't know.
Yeah, right. I mean, right off the bat, care factor 0.
Yeah. I mean, for me, it's like being able to drive a 4K screen these days, and like just that's pretty much the big thing. Like just being able to handle a CAD program while also in a Slack channel, while also having 40 data sheets open, while also just like just kind of the load of that sort of thing. And it's
in that same recent video we just talked about that I did. That was a live show. I talked about I looked at the framework laptop, which is the new Modular.
The Linux. Yeah.
I don't think it's open source. Is it open source?
I don't know.
It comes with schematic. I think you can get the schematics for it. I don't know if it's like fully open or whatever, but apparently the framework laptop. And apparently Linus from Linus Tech Tips, he invested money in it or something.
Oh, cool.
And it's this modular laptop thing, and it's like, I don't know. It's like it's got these 4 ports on the side that you can actually replace with either a USB-C port, a HDMI port, a FireWire port. A FireWire. Sorry, what's the new one? I don't know. Fire something.
Thunderbolt. I think.
Thunderbolt is what I'm thinking of. Yeah,
but that's like usually built on top of USB-C. So it's like
right. Okay.
That's like the
right. Anyway, you can modularly put in all these things. And I'm having a look at this, and I'm going, well. They didn't even and you have to power the laptop through one of these USB-C port, one of these modular USB-C ports. And I thought, well, you've just pissed away one of your 4 ports already, because that has to be your dedicated power port, right? You have to power this bloody thing, right? That's
you could switch it out
essential.
when the battery was on battery.
Maybe
I suppose,
when the battery's I don't know how they do the card edge thing. I don't know what the interface is for the board, for the module.
Yeah.
I don't know how actual reliable that is, but it's got to be some board-to-board interconnect. It's got to be high speed as well, right? It's got to be one of those high-speed board-to-board interconnects. I don't know how much they're going to, and actual, how they're going to hold up to hundreds of insertions and removals and stuff like that. But I just thought, right off the bat, I thought that was dumb, because you've got to have a USB-C port permanently attached for charging. So I thought, why piss away one of your modular things for that? And then I realized why they did it is because they decided that they wanted the screen to fold back completely on itself. That means the hinge has to be on the back side of the case. This is all a product design trade-off, right? It's got to be on the back side. Therefore, you can't have any connectors on the back of the computer. So you've only got the side or the front left, right? Or maybe you could have, if you're clever, you could have under, and then you could have like a little sneaky cutout where the cable sort of goes, in or something weird like that. But nah.
Bunny and Zobs, they did that with their laptop. They had an open source laptop as well, right? And they had like I think it was like a plug-in port, but their whole thing kind of like popped open. It was like basically like an exposed chassis.
Yes, yeah, that's right. Yeah, didn't it have like a hinge lid or something? You could.
It did,
right. Yeah, I remember that. I don't know. It's like, they try and be a jack of all trade, master of none, kind of, this modular.
I think there's
concept,
that. I think it's just where's it all gonna go? Like I don't know. I want to support stuff like that, but I need a company behind it, honestly. Like that's just one thing in my world where I just need someone to like be able to send me replacement parts, and just I need that as a tool, and that's not where I'm not willing to tinker on a laptop, because it's just like my everyday thing,
Right. Yeah, I can see where you're coming from.
If it was like a secondary, then maybe, if you had like a desktop, you're like, oh, and then I have this laptop for trying stuff out and like doing experiments and whatever. It's on the bench maybe, and like that's kind of okay, but yeah, not for me.
You just want something that works out of the box and has been engineered to work out of the box, and that's it.
I just need horsepower and reliability, and
and then right up front you choose the one that has your feature set that you want. You don't want to like I can't see that people's requirements are so constantly changing that you need this modular thing.
I think that's right. I think a lot of the times when you do see modular, people are like overdoing it in terms of like the percentage of time that people will actually need it, and then the percentage of total people that actually need that for as a like, so okay, maybe 5% of your audience, maybe 20% of your audience says they need it, but then of that 20%
only
pool,
5% of that 20% really need it. Like,
right, and it's like they're an everyday user. They're going to switch out a module every single day. This is always my thing of like the whole interoperability between mechanical CAD and electrical CAD. It's like, when you need it, that is just like the coolest friggin' option ever.
Yeah, of course.
But like, how often do you need that?
Exactly.
Like I need a box, and then the box, I design stuff for the box, and like that's how I work. But I'm not working on something like super high end. So okay, like, so then the people that need that feature are just not vanishingly small, just not me. I know it's not me, and so I count myself out in those scenarios.
Right.
I actually have. This is something I brought up last week, and we didn't. You ended up saying, "No, I don't want to talk about. I wanted to talk about this other thing."
Oh, really? Okay.
It's okay. Yeah, it was. No. You were trying to finish a point. It's fine.
Oh, okay. Right.
So I had brought up that I had just gotten Micromod, and I think this is another. I bought it. We talked about it when it came out. This is a SparkFun thing, and they use M.2, which is the interface type,
thing.
Right?
Yep.
Yeah, and they don't use the standard though. They just use the connector. Yes. And so I think it's an E-type.
I'm sure we talked about this months ago.
We did. Yeah, no, we did. But we talked about having it, and then I got it. I was like, I'll never do that. And then I got it. I was like, okay.
Got it.
So, and first off, it is very cool. I love the M.2 connector. I think that is just like the coolest little thing. And like, this is like a tiny little board.
Yep.
And I like it. I think it's interesting, and I don't know. I like that part. But I don't think most people need this sort of thing, right? Like, I don't think...
That's right. Most people don't need it.
I am never going to put an M.2 connector for this purpose onto a board to switch in Micromod boards. And I think I think that we probably did mention this when it first came out. It's like, I don't think that most people need to switch between platforms, right? That's just not something that happens that often.
Exactly.
I think it actually probably happens quite a bit at like a Spark Fun, right? Or
Exactly.
maybe
At a hobby experimental level, yes,
yeah,
it
right,
has its place. But in
right.
like serious design, serious product design, it's just not going to happen.
Yeah, the product design thing, like
Yep.
something that's going to go to production is no, but okay. Counterpoint to ourselves, I suppose. I saw someone on Twitter said that they actually made a micromod board because they only had 10 parts left. They only had 10 STM32s left that they needed to do, and they wanted to be able to switch them between parts, between boards that they were making. So, like, that is a great use case.
Gotcha. Okay. Yep.
I would like to think that is a use case that is going away, but that is a
sure.
perfect example of modularity where, like, look, I
Yep.
only have 10 total microcontrollers left. I need to deploy them to all these different tests
Yep.
that I'm set up that I'm doing. It's like, okay, that is a good use case.
Yep.
But if you designed an entire like business case around that, I feel like that would be a little reductive overall.
This is what I talked about in the live show that I did the other day. Modular
Yeah.
electronic design. I mentioned on the show how I got into like a month-long debate with some guy on the old school Usenet forum back in the like early 90s or something, right? About, oh, the future's modular, right? You won't have to design everything.
You see, kids, people didn't used to argue on Twitter. They used to argue over
Usenet.
bulletin boards.
Yeah, bulletin boards and Usenet and BBSs and stuff like that.
You see, kids, a bulletin board is an electronic version of a piece of cork that old people used to stick to the walls to find rides places and get guitar lessons.
So anyway, I do believe from memory, I think this guy wanted to go into business with me, and he had this idea for modular electronics, and I'm going and I just spent like a month or more trying to convince this dude that this is never going to take off. It's never going to be a thing. And then, of course, it never happened. And then when I joined Altium, it was like, oh, Altium's wants to do modular electronics. Okay, here we go again. Yep. And the eyes rolled in the back of my head. And, seriously, that was the vision. That was one of the Altium vision, was that nobody would want to design their own fully custom PCB anymore. Because why? Why? Because like lay out a board from scratch. Why? Because every product has a switch mode power. Like just assume every product has a switch mode power supply, right? Yeah. Because somebody, right? It's already been done 1 million times. Why redo the layout for a switch in power supply when you can simply take that module and drop it in, and boom, your product's done? It's like there's just so many reasons why this was never going to work. And the vision, it makes for a great wanky vision, but in practice, it's just there's so many reasons why it's not going to work. It's just ridiculous.
I think it's the same scenario where it's just like, for some people it makes the most sense, right? It is the answer,
right?
But I don't think it's the mass market, and so I think that's just it's overplaying a hand, right? It's like
can somebody name a product out there in the audience? Can somebody name a product that uses modular design like this effectively, and it's famous for it, and it's the lead-in product in its field because it's modular? Maybe on like PC server, like you get the plug-in power supplies and stuff like that, but that's all. I don't even think there's a standard for that. There's like, HP have their own plug-in power supplies, and it's all, it's not sort of some universal standard type thing. Can anyone think of anything? PC 104 comes to mind, I guess. I've done a video on PC 104 standards which is a thing. It is still a thing, but it's not a big thing. It's one of those, niche kind of industrial control kind of things. Again, I don't see it. I can't think of anything.
I think cost always runs into it. Like there's cost of connectors,
cost and optimization, and the engineers designing the thing. They go, no, I don't want to use that chip. That's a pain in the ass. We use this on all our products, so we're going to use this again, and we're going to, there's just so many reasons. Or no, I hate that company. I'm not using their chip. Piss off. They've burnt me before. No, I'm not going to. Right.
Yeah.
And of course, at the large, ultra large scale, I mean, you engineer cost is everything, right? You engineer everything to save cost, and then you get, if you're an Apple or somebody, you get such huge deals from the manufacturers because you're ordering 10 million chips, right? It's just, it's nuts.
Well, I think the other thing too is that, like, okay, so an Apple, maybe at the beginning, that's a bad example of Apple, but like let's just say large company at the beginning, it makes a lot of sense to have this modular thing for swappability and to be flexible and nimble and whatever. And you could say, let's keep doing it, but like there's always, even if there's not like cost pressure in terms of like margin,
there's always some other engineering reason to do it.
Engineers are there for a reason. That's what it comes down to. Is that like, they're like, well, we hired all these engineers. What the hell are they doing?
Right.
Okay, go cost down a product. Like, get out of here, man. Like, go do your job.
They are building Lego, right? They're not just, geez, I could have done that myself. I just could use these boards and plug them all together, and there's our product. It's like,
exactly.
Yeah.
So I think that always comes up, and like, so I've seen this kind of like system level, like as well, like, having this ultimate flexibility is great, and people are willing to pay for it at the beginning of a setup. But I think then it's just, at some point there is like a efficiency, not an efficiency, it's like a cost trade-off where it's like, okay, well, we could keep, like, so the cost of modularity, say you have to pay like $5 a month to maintain the modularity on this thing. It's like, okay, that sounds fine at the beginning, but that $5 a month per whatever you're selling, like, scales linearly. So you do that for, 100 devices. Okay, $500 a month, we can handle that. But now we're selling 5 million devices. Okay, so 25 million. How many engineers could I hire for 25 million? I could probably hire 5 engineers and, pay them, a couple $100,000 a year and get rid of $24 million of cost. It's just like, oh, we're going to do that. So at some point, there's always like a crossover of like, just hire someone to go make it cheaper.
Don't underestimate the like when you hire a new engineer, they want to prove themselves, so they do that by making changes. It's like when you hire a new management or a new company CEO, right? The first thing, they come in and change everything because they want to justify that they're, nobody, like, imagine if you're a CEO coming to a company and go, I'm going to make no changes whatsoever.
Right.
It's like, well,
everything's good.
Why the hell did we hire you?
Yeah, you guys shouldn't have hired me.
It's the same with engineers too, right? You hire an engineer and they'll come in and they've got their ideas and they want to prove to you that they're clever and that they're, genius, and they're going to save you money and they're going to optimize it and they're going to do everything. And if you get the wrong engineer, they can optimize your company straight into the ground, Yeah. So
I think that's interesting. I've had to deal with that I've had to deal with my own inclination to do that sort of thing.
Right. Yeah.
So like, I come into a consulting job, right? Someone's like, hey, we had this system, we want you to work on it. I'm like, okay, cool. And like, sometimes the right answer is to not do that, right?
Is really to not do anything. Tough. Is to, you're doing it fine. Like, but you feel as though you're not contributing. You feel as though you're not earning your keep. Right, so you've got to make.
In my case,
forced.
I literally don't make any money. I literally
right.
Yeah,
of course.
That's the really tough thing. But I think that, like, I've talked to a friend about this, another consulting friend about this too, and it's like, but if you think about the true like output of a job is like your good name and like being recommended for the next job and the next job and the next job, and like those good feels, that's actually what you're getting out of it. And it is so hard to do that versus like, oh, well, I could probably bill them like, I don't know, 200 hours to, to go and redo this thing. And I have to not do that. So, yeah.
Pesky humans, they just want to change shit. Yeah.
Yes. Yep.
Annoying.
Yep. Yeah.
All right.
Sometimes you just go and change the name of your company, and that's a story too.
Is it? Is that a story?
Meta.
Oh God, no, that wasn't even on the
We're
list.
Not going to talk
about it.
Sorry, I'm just scrolling down my Twitter feed now.
Oh, now we're scraping the barrel.
Meta. No, I have something I want to talk about. I am gonna probably be at Embedded World, which is in Nuremberg in March.
Nice.
Yeah. So if there are people out there listening,
is this a company thing or is this off your own bat?
This is a company thing. Yeah. So,
right. Okay. Yep.
Yeah. And so I've never been before. I've heard about it. I actually have a friend that has been a couple times because he actually
I've
lives
heard
pretty
it's
close
huge.
in
Yeah.
Nuremberg. Yeah.
Well, I don't know how huge it'll be this time because, the whole...
Yeah. Yeah. It'll
Some
definitely
things
be the
going on in the
biggest one that
world,
I'm
but
going back to.
right.
We'll
Definitely.
see.
Yep.
Yeah.
Cool.
Uh,
Speaking of which,
yeah.
the electronics trade show has just announced that it's coming back in March, I think. Don't quote me on it, but March.
Well, sorry, Dave, I
2022 in
can't go.
Sydney.
I can't fly to Sydney instead of Germany.
Why?
To go to.
Yes, you can.
Well,
Come on, the company milk that cash cow company you're working for. Come on. I'm sure you can.
I just mean,
this is a huge show in Australia. We have to have a stand there. We have to.
Yeah.
And come on.
Oh my God.
Yeah. What?
Yeah.
You don't think our dinky little electronics show here is good
enough? So I didn't want to say it.
Our little rinky dink.
How would I say this nicely in Aussie plus?
Yeah, nah. Just give me a yeah, nah.
Reckon I'll have a walkabout until that trade show gets bigger.
Right. Come on, there's a good 50 stands there.
Yeah, that's like a whole afternoon.
Right, yeah, exactly. And so you spend more time on the plane than you do walking around.
Yeah, that's right. Yeah.
Literally.
Yeah.
Oh boy. Yep. Come on, don't disparage our little Aussie Battling trade show.
I think I will. You're gonna go though?
Oh yeah, of course. Yeah. Oh yeah, it's here in Sydney.
Cool.
You
guys are doing it wrong though. You should try and get a big one to come there, and then have everybody would want to come to down under, and
everyone would want to go to Australia. Of course, everyone wants to go to Australia. All their companies. Yeah. Right.
Come down, eat some ridiculously cheap avocado toast. Now that the avocados are cheap in Australia.
Yeah, exactly.
Yeah. Another news article from the week.
Yep.
Yeah.
Quality content here on the Amp Hour. Yep. Quality relevant content.
Yeah.
How would you do that? How would you convince people to come to, how would you, money, right? That's how you would convince them. You go, we'll pay you to move your trade show here.
I guess so. Yeah.
Yeah.
I think you'd have to have someone so important that they'd say oh, we have to be down there so such and such will go or will attend or whatever.
Yeah, right. It's a chicken and egg.
It's always like a center of gravity kind of thing. Where people are like, oh, I'm only going to go to the big trade shows, and the big trade shows are only going to be where all the people are. And it's like, oh okay, well, how do we
right.
how do we get this moving here? So yeah, that is one way to do it.
Yep.
Last thing that I have, this is the bottom of the barrel. So we did talk a little bit about the Kicad debacle with the website moving, and the website, being sold out from under them by a past developer.
Is there some update there, or?
There is. So it was just a landing page before, hosted by GoDaddy or whatever. But now someone actually cloned the site, and the only thing they changed on it so far is that they removed how to verify the download after you've downloaded the package. So if you go and download Kicad from the old site, which is kicad-pcb.org, do not download anything from there. The correct site is kicad.org. If you go to the old site, they've basically cloned the site, so it looks exactly the same. If you click on downloads, the only thing that's different right now is they've removed how to validate that the package is correct with CRCs, or I forget how the hash of the download.
Okay, so I am now at kicad-pcb.org.
Yes.
And you're saying that's not the right one, in quote marks.
That is correct. That is a scam site of some type.
They've got a donate button in the top right.
That goes to the same place. That goes
CERN
to
and Society Foundation.CERN/
That's right. That is the official. Well, I'm not sure when you actually click.
Hang on. So you're saying this bogus site is linking to the official donate for the CERN Kicad project?
That's right.
I don't see the problem. Why is that a problem? Why is that a problem?
What happened the last time is that they basically whoever used to own kicad.org, the old site, basically hosted a malicious version. Basically, it was like spyware inside of the Kicad binary that you download.
Right. Okay.
And basically what it seems like this person is going to do is try and look legit enough so that people go and hit download, but there's no way to tell that it's a malicious download, right? So if you click download right now,
so has this been verified that the actual download is a spyware version?
There's no way to tell that right now. The only thing that's happened is that they've cloned the site so it looks legit,
right?
And they've removed the thing that says, so if you go to kicad.org and then download, you'll notice on there it tells you how to check the signing of the package. That is not on the now bogus site.
Right. So given that somebody who owns the trademarks to Kicad and stuff, surely you could slap if it's hosted in the US, you could slap a DMCA takedown on the site. Why doesn't somebody do that?
The Linux Foundation owns it.
Yep. Well, why don't they slap them with a notice a takedown?
They're working on it.
Oh, okay.
They're working on it.
Right. Yeah. Got it. All right.
Yep.
Cool.
So just
okay, there you go. Well, that's sneaky. So do we know who is actually behind this site, or is it just a
nope? There's no.
Nope. Really? So we don't. Right. It's just a. And they went to all this effort to target this niche product so that they could install spyware. Like
that's I don't know. This has happened before. I'm not sure why. I think it's kind of like, like sometimes when you go to like, what is that? They hosted a bunch of like freeware on the site. Oh, I can't remember it.
But it's got to be someone in the community, right? Otherwise, who would know it? Like your regular, scammer is not going to know what the hell Kicad is, right? So it totally. Just doesn't make sense.
Dave, I don't get it, man. Like I don't. It's a lot of work for what's the payoff here? But I'm just telling like this is our job to do public service. So this is a public service announcement.
Wow.
Yeah. It's really really annoying because I've been chasing down old links and just
Yeah, because it looks totally legit. Where does it appear in the Google search? Does it appear in the Google search?
It does not appear in Google right now.
Okay, right. Well, that's good. Yeah. Because this looks totally legit.
But there's like 100,000 links to the old site still. So that's that's the problem, is that you still have just like the carcass of this old site, being linked to throughout the internet. Like who goes through, like if you don't own a redirect, right? If you own a redirect, if you own both sites and you redirect the new one, that's fine, right? But if you don't own that old site, there's just all of these like vestiges of old links that still point, like even some of my own sites, I had links to the old site and there's just nothing you could do. So
wow,
it sucks.
Okay. So the thing is, the official page, which is kicad.org, is that correct?
That's right. That is correct. Yes.
So the official legit page is kicad.org. Why don't they have a huge banner on the front page saying this other site is not legit? This other site is bullshit. That's a
good idea.
Like,
they should change. They should change the look and.
There should be a massive banner. So if they want to copy it, it's like, well, they'd have to copy this banner saying that this site's not legit. But obviously, they wouldn't be dumb enough to do that. They'd take it out. But then, no, they need to put, if this is that serious, then they need to put a gigantic banner on the front page telling people about this.
Yeah. Good idea. Yeah. Good idea. I'll pass that along.
Yep.
It's just a lot of
yep.
A lot of BS. It sucks.
Yep. Nasty. Oh, I can't remember who the company. This reminds me of another company that had to do this. It was in our space, and they had to put a big big banner warning on their website, going, "Oh, this source is not a legitimate source. Here's the, here is the official version and stuff." And because this other person, they just stole their site or whatever. And so it has, wow. But it's got to be someone in the community. But I don't, wow. It's weird. Anyway, there you go.
It sucks.
Yep. Do we have any last news, last comments? Because our amp hour's up.
No, give me a message if people are going to the embedded world, let me know. Shoot me a message. Love to hear from you. Maybe I'll try and do a, safe meetup if we can.
And if you're going to the electronics, the Superior electronics show here in Sydney in March next year. Yep.
That's right.
I'll
That's right.
have to
It's
do
a
a
tough
meetup
choice,
thing too.
folks.
Yep.
That's a tough choice, but choose your plane tickets wisely.
Come to Australia; it's way better.
It's way warmer. I'll give you that.
Oh, okay.
And your programming languages are cheekier.
Vastly superior. Yep.
Yeah.
Cool. All right. Well, catch you next time.
See you.